Distance time graphs and displacement time graphs. Is there a difference? Yes. Hello and welcome to Underdog Physics. Distance time graphs and displacement time graphs allow us to analyse how an object's position changes over time. Consider this grape. It's currently at this position, by which I mean the centre of the grape is currently at that position. The grape will now move along a square path. Why? Nobody knows, but we'll keep track of what it's doing with a distance time graph. Let's consider this square journey to have 4 legs, A, B, C and D. Each leg of the journey is 12 centimetres in length. We can describe the grape's journey like this. The grape moves at constant speed along A. It takes 2 seconds to cover 12 centimetres, which is 6 centimetres a second. It then waits at that corner for 2 seconds. Its speed is 0 centimetres a second. It then moves with constant speed along leg B, covering 12 centimetres in 1 second, which is 12 centimetres a second. It also covers leg C with the same speed, 12 centimetres a second, then takes 4 whole seconds to complete the last leg of the journey, moving at a speed of 3 centimetres a second. If we look at the graph, we can see these 5 distinct sections of the journey as well. The first section has a constant gradient, showing our constant speed. Section 2 has a 0 gradient, showing that our grape is not covering any distance in that time, so 0 centimetres a second. The next 2 sections of the graph are quite interesting, since our grape moves in 2 different directions, upward then to the left, but graph sections 3 and 4 don't give us this information. It does, however, tell us that our grape is moving at the same speed in both of these sections. After all, the grape covers 12 centimetres in 1 second, then another 12 centimetres in 1 second. And our graph has the same gradient for both of these sections, because our grape has the same speed in both of these sections. Note also that our gradient is steeper in sections 3 and 4 than in section 1. In fact, the gradient is twice as steep, since the speed is twice as fast. Lastly, graph section 5 shows the grape moving at a slower constant speed. Since the grape takes 4 whole seconds to cover the last 12 centimetres of the journey, the gradient of section 5 is half as steep as the gradient in graph section 1. You guessed it, the grape's speed in leg D was half the speed it had in leg A. Now, looking at our grape's journey in real life, we can see that it ends up back where it started. But our distance time graph doesn't give us this information. After all, our graph is only keeping track of the distance covered, which, to be fair, shows us that the total distance the grape has covered is 48 centimetres. If only we could show displacement. To be honest, I think displacement time graphs need a whole video for themselves, but I won't leave you high and dry. For now, I'll tell you that when we're drawing displacement time graphs for a moving object, we need to decide upon a direction of reference first, since displacement time graphs consider movement in only one direction. To quickly show you what I'm on about, I'll plot 2 displacement time graphs for our grape's journey, and maybe I'll make a YouTube short or something to show a model solution to a question. Watch this space. Here's our grape again. It's ready to do the same journey as it did before. The graph on the top left will show us how its vertical displacement will change over time, and the graph on the bottom left will show us how its horizontal displacement will change over time. Let's go. Thanks so much for watching. I hope you found this useful. Please do feel free to suggest videos you'd like to see in the comments below, and subscribe if you haven't already.